Pre-calculus, logarithmic functions. How do I get a clean answer? And the post is asking for part B, which is this question here. So let's have a look. We have the equation log base 8 of 5x squared is equal to log base 2 of 4x. So this equation has two logs and the bases are different, so that's interesting. How do we take care of it though? Well, first we can use the change of base formula. So let's go ahead and start with that. Here's a quick note. When we have log with some base b of some input a, this right here is equal to log of this input over log of this base b. And notice that I'm just using the regular log. So that means log base 10. You could also use ln, the natural log. As long as the top and bottom logs are equal, this is okay. So for this part right here, I will rewrite it as log base 10, and this input is 5x squared, and then over log, the 8 now is the input, so it's log base 10 of 8. And we do the same thing on the right hand side. This is log of 4x, and then log 2. One thing I want to mention real quick is that notice right here I didn't use parentheses because we only have one thing or one number inside. If you have more than one thing, then you should really use parentheses like this right here. All right? Now, how do we continue? That's the main issue. Here, the 8 is the key. 8 is the same as 2 times 2 times 2, which is 2 to the third power. So right here, I'm going to write that as 2 to the third power. Right? That's the key right here. Why though? Because now I can put the 3, the power, to the front like this. So we get log of 5x squared over 3 log of 2, and that is equal to log of 4x over log of 2. Now, both fractions has log of 2 on the bottom, so they cancel. And then you can multiply 3 to both sides, so this and that cancel. So we are looking at log of 5x squared equals 3 times log of 4x. Can we get rid of these two logs? Not yet, because the coefficient here is 1, this coefficient is 3. Take care of the coefficient first before we get rid of the log. To do so, we can bring this 3, right, the coefficient, back up here to be the power. And be super careful though, because we have two things here, use the parentheses. So right here we actually get log of 5x squared being equal to log of parentheses this to the third power, and the inside here is 4x. Now, when we have two logs equal to each other and the bases are the same now, that means the input has to be equal. Earlier I couldn't do that because the bases are different. Right now we could because this is log base 10, likewise that. So we can continue. We are just going to get 5x squared being equal to 4x to the third power. And now it's just a regular equation with no logs, so just worked out. This is 5x squared equals 4 to the third power, 64x to the third power. Subtract 5x to both sides, 5x squared to both sides. So this is 64x third power minus 5x squared. Factor out x squared. So we get 64x minus 5. So that means x squared equal to 0, or 64x minus 5 equal to 0. This is saying x is equal to 0, and this is saying add 5 to both sides divided by 64 to both sides, so x is equal to 5 over 64. Two answers? No, this is not allowed. Because, I'll just say, let's just note, log of 0 is not defined. Even though when you put 0 into here, you get like undefined, but you never say undefined is equal to undefined, like 0. So you don't really consider this as the answer. Just don't do that. And in fact, if you graph it, if you graph this and you graph that, like y is equal to this, y is equal to that, you actually don't see an intersection at x equal to 0. So 0 is not an answer, right? This is not good. So the only answer is x equals 5/64. And we're done, just like that.